Hello and welcome to computer programming. All right, so today we are going to be writing and creating our first program. All right, and it's going to be a little like change calculating program. So, for example, if I was like, oh, I needed 77 cents back, it would be like, okay, that's 3 quarters and 2 pennies. Or, oh, I need 42 cents back. Well, that's 1 quarter, 1 dime, 1 nickel, and 2 pennies, and so on and so forth. All right, so that's what the program is going to be able to do. Before we get to that, though, I want to have a discussion about variables, all right? Because it's pretty hard to write a program that does anything of any interest without making use and creating variables. So to do that, we need to start by getting the files that we're going to use today. So in your Google Classroom, you're going to see something called Making Change. And you're going to see a file attached to that assignment called intro makingchange.zip. All right, so you're going to want to click on that. Now, when you click on it, this window is going to pop up and it says couldn't preview the file. And the reason is it's just like the types of files we're using. Also, what is attached is what's called a zip file. Now, there are different options here: zip extractor, cloud convert, document viewer for Google Drive. We don't want to use these. All right, so I'm going to click on this for a second, but don't actually click on it when you're doing it on your own, because this zip extractor extracts things to Google Drive, and that doesn't help us. We don't want our files on Google Drive. We want our files on the actual computer so that we can run them through our code block software. So if you save them to Google Drive, then you're just giving yourself an extra step because you have to download them from Google Drive. So instead, what you're going to want to do is these 3 little dots up here where it says More Actions. You're going to want to click on those. You're going to choose Open in New Window. And then once you do that, it's going to open it up in a new tab. And now you're going to have this download icon that wasn't there before. All right. So if you click on the download icon, it will then download the files directly to your computer, which is where we need them, which is where we want them. So that's what you're going to want to do to get access to them. Now, where did those files go? All right, they most likely went to your downloads folder. So if you click on Windows Explorer down here at the bottom on your toolbar, the one that looks like a little folder, and then you click over on the left-hand side here under the Quick Access menu, one of the choices should be Downloads. And then you're likely to see the computer programming folder we made last class, and you're likely to see this zip file, Intro to Making Change. Now, a zip file is like an easy way to send a whole bunch of things at once, but we can't use them in their zipped formats. So we have to unzip them if we actually want to use them. So to do that, we're going to right-click on this. One of the choices should be Extract All. You can just click down here on Extract. You don't have to change anything there. And then it will extract them and open up the window. Now, I'm actually going to close this window to show you kind of what it did. So I'm back in my downloads folder. There's the zipped version. There's the unzipped version. Once you've unzipped it, you don't need the zipped version anymore. So I can just delete this because I don't need it anymore. So I'm going to delete the zipped version, and then I'm going to drag this version into my computer programming folder just to help keep myself organized. All right. So again, just kind of reviewing that really quickly. I clicked on the 3 dots to open in a new window. All right, that opened it in another tab where I could download it. All right, once I've downloaded it, that will send a zip file to my downloads folder. And then if I right click, I can choose Extract All. That will give me the unzipped version. And then once I have the unzipped version, I can drag that into my computer programming folder. Now, I've already done all that, so I'm just going to delete both of these since they're duplicates. But in here, I now have the Intro to Making Change. And then if you open up that folder, the file that we're actually going to click on is the first program project file. So there's a whole bunch of different things in here. The one we want to open is the project file. All right, so if I double click on that, it's going to open up code blocks. Now, if you're not seeing this code, you just have to go over to the navigator here and make sure you go over to the projects tab. There's little arrows here to go between the different tabs. So in the projects tab, the sources folder, if you click the plus sign, you should see main.cpp. And then if you double click on it, the code should then show up in this window. All right, so right now we have some starter code here, and that starter code doesn't actually do anything. All right, it's just a bunch of variables that I've created, and some of them have starting values and some of them don't. All right, so let's just talk a little bit about what's a variable. All right, a variable is how we store information in our program. All right, so if we want to hang on to information, if we want to use information, if we want to be able to manipulate different values, we generally have to store those values in a variable. All right, so what I've done here on line 7 is I've created a variable called a, and I've stored in that variable the number 2. All right. Now down here, I've created a variable called b. I've stored the number 4. Here I've created a variable called c, and I didn't put anything in it. All right. So these variables up here are what are called initialized because they have a value in them. C is uninitialized because I didn't give it a value. I created it. All right. I've said that this program now has access to a variable called c, but nothing's been placed in it yet. All right. Then down here, I pretty much did the same exact thing. I created 3 more variables, 2 of which are set to 2 and 4, and the other one which is uninitialized. So what's the difference between these top 3 variables and these bottom 3 variables? All right, well, it turns out in C++, when you create a variable, you have to let the computer know what type of information you're storing in the variable. All right, so there are a bunch of different types of variables. 2 of the most common, and the 2 that we're going to be using a lot at the very beginning, are ints and floats. All right, both of those are able to store numbers and numbers only. The only difference is int is short for integer, so it cannot store decimals. Float is short for floating point, and it can handle decimals. Right? And this is all relevant because depending on what types of numbers you're dealing with, the program needs to use like different circuits on the processor chip and handle the numbers differently. So we have to kind of specify what type of numbers we're dealing with so the computer can treat them or handle them appropriately. Now, there are other types of variables. There are Boolean variables. There are character variables. There's different versions of ints and floats. One is called long, one is called double. But for right now, we're going to focus primarily on ints and floats. Now, when you create the variable, you do have to specify what type it is, int, float, so on and so forth. But after you create the variable, you no longer need to use the ints and floats. So from this point forth, I can just say ABC or XYZ, and the program will know what I'm referring to. I don't have to say int A anymore. I don't have to say int B. I don't have to say int C. Right? And in fact, if I try to say int A, int B, or int C, I'll get an error. All right, so it's only the very first time that you have this int and float there. All right, it's when you're declaring the variable. Now, what we're going to do next is I want to just show you how we can interact with some of these variables and some of the different things that we can do with them. All right, so let's say we wanted to do a little calculation. All right, I could go down here and I could say C equals 2 divided by 4. All right. Now, when I did this calculation, it was important that I put C on the left, all right, because this equal sign is really what's called the assignment operator. And what it does is it takes whatever's on the right-hand side and assigns it to the left-hand side. All right. So when you're doing calculations, when you're doing different pieces here, the calculation always has to go on the right-hand side. The answer or where it's being stored is always on the left-hand side, and it has to be there by itself. right? I couldn't have like C plus A over here or anything else. It just has to be the variable all by itself. All right, so I could do C equals 2 divided by 4, and then I could print out the result. So to print out the result, I'm going to use the cout command that we saw last class. Now, the only difference is I'm not going to use quotation marks because quotation marks are for text. I want to print out not the letter C, but the variable C. So I'm just going to do a C without quotations, and then I'm going to do less than, and L just to print it out there. So if I were to run this program right now, and again, we can run our programs by going to build and run. All right, and this little security scan is probably going to pop up the first couple of times, but you don't have to worry about it. You can just kind of click it away. And then eventually the program will run, and it's going to tell me that 2 divided by 4 is 0. All right. Now you might be saying to yourself, 2 divided by 4 is not 0. What's actually happening here? All right, so what's happening is that C was an integer variable. All right, so integer variables can't store decimals. So when I tried to do 2 divided by 4, yes, we know that 2 divided by 4 is 0.5, but the 0.5 can't be stored in there. So instead, it's just a 0. Now, you might be saying to yourself, but wait, doesn't 0.5 round up to 1? You're right, but we don't round, all right? The decimal just gets cut off or truncated. So 2 divided by 4, when we're dealing with integers, would just be 0. Now, I don't just have to do actual numbers here. I could also use the variables. So I could do A divided by B. And what that's going to do is it's going to automatically plug in the 2 that's associated with the A. It's automatically going to plug in the 4 that's associated with the B. It's going to do 2 divided by 4. But again, because this is an integer, the decimal is going to get completely cut off. So if I were to run this, there it is. I'm getting the same 0 that I got before. All right. So let's move over to the floating points, all right, because these are the ones that have decimals. All right, so what I'm going to do is I'm just going to change this C. Let me zoom in a little bit here. Oops. I'm going to change this Z, the C to a Z, and then I'm going to type in 2 divided by 4. And then I'm going to print out Z. All right, now when I run this, let's see what happens. All right, so I'm going to go to build and run. Again, you can get to it from the menu here, build and run, or this little symbol with the green triangle and the gear, that's build and run. So you can also just click on that. And you're going to see that I got the same number, 0. You might be saying to yourself, Mr. Vona, you just said floats could handle decimals, so why are you still getting 0? All right, the reason I'm still getting 0 here is that 2 is an integer and 4 is an integer. All right, so when the program is running, it says, oh, I'm dividing 2 integers. Let me use the circuits on the chip that handle integers. So it uses those circuits. And when it uses those circuits, it doesn't get 0.5, it gets 0. So that automatically stores it in Z. It doesn't matter that Z can handle decimals. The calculation was purely integers, so the decimals got cut off. Now, if I were to change this to 4.0, all right, then that would let the computer know that, like, oh, okay, we're using decimals here. So when I do the calculation, I have to use my circuits that can handle decimals. And now I'm getting the 0.5 that we would have expected in the first place. All right, so be careful. Just because you're using a float variable doesn't automatically mean you'll get those decimals that you're looking for. Now, if instead of typing in 2 and 4, I type in x and y, all right, you might notice that this is just x equals 2 and y equals 4. But because these are float variables and I'm doing the calculation with float variables, my answer will have the decimal. So I don't have to worry about saying x equals 2.0 or y equals 4.0. Because these are float variables and they're part of this calculation, the computer knows to use the circuits that can handle decimals. So when I run this, I will get the 0.5 that I was expecting. All right. So for the most part, what you need to be aware of is that if you're using all integers, any decimals are just going to get cut off. If you're using all floats, then the decimals will work. And then if you're using constants, you just have to be careful, all right? Because depending on which constants you're using, again, if I just did it like this, it would end up doing a 0 because it would think it was all integers. If I did something like this, then it would recognize that I'm looking for a decimal answer and I would get the correct result. All right, so just be aware of that you do have to kind of be careful depending on which type of variables you're creating, and then the implications of creating those variables and what it can do. Now, where it can sometimes get a little tricky is when you start mixing and matching. Now, to be honest, there's not going to be that many times when you are mixing and matching. Usually you'll either be using ints or you'll be using floats, but it's good to at least sort of understand that you can mix and match and then understand the implications of mixing and matching and what can potentially happen. So what I'm going to do is I'm just going to run through a couple of examples here so that you can see what happens when you mix and match. So the first thing I'm going to do is C equals X divided by Y. All right, so C is an integer variable, but X and Y are floats. So let's see what happens when I print out C. Let's see what answer I actually get. All right, so if I run this, you're going to see that I get a 0. All right, reason I get a 0 is, yes, these are both floats, so it knows to use the float circuits, but then when I try to store it in memory, this memory can only handle integers, so the decimal just gets cut off, and that's why I'm left with my 0, because instead of getting 0.5, I just get 0. So if you're doing floats, but you store it in a integer variable, it's going to get cut off. All right, now let's do the reverse. Let's do integer variables and try to store it in a float. So if I do A divided by B here and try to store it in a float variable, all right, let's see what happens. I got 95, which means I think I typed something in wrong. Because I'm still typing in C. Now, that's a good point there. So, like, why did I get 95? That's a good teachable moment there. The reason I got 95 is because C is uninitialized, which means I assigned a spot in memory for C, but I didn't give it a value. So it's just whatever happened to be in that spot of memory is what's currently in C. So when the program created the variable C, it gave it a location in memory, and it just happened to be that that memory must have formerly had the number 95 in it. So when I print out C, I'm getting that number 95, not because that's the value of C, but because that's just what happened to be there in memory. So you do have to be careful when you create a variable and you don't initialize it, because you could end up getting weird answers like I just got there of 95, because it was an uninitialized variable. Now, let me go down here and change this to Z, and then we'll see what happens. All right, you're going to see that I got a 0. All right, why did I get a 0? Again, these were both integers. So the computer was like, okay, I'm calculating 2 integers. Let me use the integer circuits. So the decimal was cut off before it even had a chance to get stored in Z. So it doesn't matter that Z can handle decimals. The decimal never made it that far because it got cut off right here. All right. So we know that if we take 2 integers and try to store it in a float, it's not going to work. What happens if I have an integer divided by a float? All right, so this is my integer 2 divided by my float 4. All right, in this case, because one of those two is a float, I am going to get my decimal because I'm storing it in a float variable. All right, if I tried to store it in an integer variable, then the decimal would get dropped because, again, the answer just can't be stored in C. So I would just get the 0. All right, it would use the float circuits, but then the answer would get stored in an integer and the decimal would get cut off. All right, so for the most part, what you have to realize is if you're trying to store it in an integer variable, the decimal is going to get cut off no matter what. If you're trying to store it in a float variable, it can depend. All right, if you're only using integers in your calculation, the decimal is going to get cut off before you even try to save it. All right, if you're using a float, then it will work and you will get your decimals, with one exception. All right, there's like one sort of detail that I want to kind of point out here. So when a computer is going through and doing these calculations, it is following the order of operations. So let me show you a little more involved calculation. All right, so I'm going to say Z, so this is a float variable, and then I'm going to say A divided by B times Y. All right, so this is basically, zoom out, I'm zoomed in a little too much now. All right, 2 divided by 4 times 4. All right, so 2 divided by 4 is 1/2 times 4 brings me right back to 2. All right, so this should have an answer of 2. All right, now based on the way I'm talking, you can probably guess that it's not going to have an answer of 2, but let's see what the answer is when I actually print out Z here. So when I tried to print out Z, you're going to see that I get the answer of 0. Why do I get the answer of 0? Well, the computer follows order of operations. So division and multiplication have the same priority. So it does the calculation left to right. So it starts by doing A divided by B. And it says, hey, A divided by B is 2 integers. So I can use my integer circuits. 2 divided by 4 is 0. Then it does 0 times Y. And it says, oh, I have to use my decimal circuits, but 0 times 4 is still 0. So the answer gets stored as 0. All right, so when you're mixing and matching here, the order in which the operations happen can affect your result. Now, watch what happens if I do this. Y times A divided by B. Now, in theory, if we're just doing regular math, this gives me the same answer, right? 4 times 2 is 8. 8 divided by 4 is 2. But you're going to see that this gives us a different answer this time. All right, so when I run it this time, the Y times A happens first. So that's 4 times 2. The decimal circuits are invoked, and I'm going to get the correct answer. All right, so there's the 2 that I was expecting. All right, so because it did this part first, anything that I do at this point, the decimals are going to happen. Now, you might be saying to yourself, Mr. Vaughn, that's not a great example because technically there weren't any decimals there anyways. Okay, it's a fair argument. So let's change this to a 5. All right, so if I change this to a 5 and then I rerun it, you're going to see that I do get the 1.6 again, because by using the Y first, the decimal circuits were invoked. It's treating this as a float answer. So it's doing a float divided by an integer, and it's giving me the correct answer. So again, you just have to be tricky. You have to be careful when you're mixing and matching ints and floats because the results aren't always super intuitive. Now, again, like I said in the beginning, to be fair, most of the time you're not going to be mixing and matching. You're going to be doing one or the other. So it's a little simpler. You know, anything with ints, the decimals are going to disappear. Anything with floats, the decimals are going to be there. But there are occasions when you might mix and match, especially later in the course. There's going to be times when we mix and match. So it's good to just be aware that there are implications to mixing and matching, and it can affect sort of what happens. All right, so that's kind of our introduction to variables. All right, you create a variable by specifying the type, and then you give a name to the variable. If you give it a starting value, it's initialized. If you don't give it a starting value, it's uninitialized. All right. The main two that we're going to be using right now are ints and floats. And then the only other thing I want to say is when you're naming your variables, I just use single letters here, but you can give them, like, it can be a word. Like this could be variable apple, this could be variable banana, this could be variable carrot. That's all fine. The only rules are it cannot start with a number. So I couldn't do 7 apple, but I could do apple 7. All right, there can't be spaces. So I can't be like apple pie and have that be a variable. If I wanted to have a space, I could either do it with like an underscore, and that would be fine. Or what's actually more common is something called camel case, which is where you put the words together, but after the first word, you capitalize any words that follow. Follow. All right, so so that would all be examples of like camel case. All right, so again, keep your variables generally like relevant to what they're being used for, but also try to keep them on the shorter side, because if you make them long, that means you have to type them out each time. So basically as short as you can make them where they still convey like what they're being used for. All right. So with that said, I now want to move on to the actual program that we're writing today. And the way this is going to work is I'm going to introduce it to you. We're going to start it together, and then you're going to have to finish it on your own. All right. So what I'm going to do is I'm actually going to delete all of this code right here. All right. So I'm just going to highlight this all, and then I'm going to delete it. And you might have noticed that there was some writing down here. All right. This is what's called a comment. All right. It's a comment because it doesn't actually run, but I can put it in my program so that other human beings can read it and have a better idea of what my program is doing. Now, this isn't actually like a traditional comment. This is code that I wrote that I just didn't want to run at the start. So what we're going to do is we're going to remove the comment. And we do that by getting rid of this / and star. So I'm just going to delete this. You're going to notice that it all of a sudden changes color. And then I'm going to go down here and delete this, which previously marked the end of the comment. And now I've got this code that's going to kind of be the start of our program. So as I kind of said, this program is going to allow us to calculate change. So the way that's going to work is somebody's going to type in a number from 0 to 99, and then we're going to use that number to figure out what change they get back. You know, how many quarters, how many dimes, how many nickels, how many pennies. All right. The variable change is an int, which means we're not going to be dealing with decimals. Now, the first thing people usually want to do when they get a programming assignment is sit down and instantly start writing code. And I get it. It's fun to write code. It's interesting to write code. It's why you took this course. But your first step should actually be to slow down and think about the problem. All right. Computer science is really about breaking down the problem into steps the computer can understand. So we have to think about this problem and say, all right, how am I going to tell a computer how to calculate change? All right, because as human beings, we just sort of do it intuitively. If you tell me that I need to get back, 62 cents, I'm going to be like, oh, that's 2 quarters, a dime, and 2 pennies. But what did I actually do in my brain to make that happen? All right, if I was instructing someone that didn't know anything about our money, how would I instruct them to calculate change? Right? So that's what you really have to think about when you're writing a program. How do I take this task and break it down into steps that the computer is going to be able to understand and carry out? And my steps have to be detailed enough that they can handle different situations and there's no confusion about what needs to happen. So what I would encourage you to do right now is pause the video, not like actually right this second, because then you won't hear what I want you to do. But I want you to eventually pause the video and ask yourself, all right, if I was trying to tell someone or try to explain to somebody how to calculate change, how would I do that? All right, so pause the video and think about that. All right, hopefully you gave it some thought. Hopefully you then just unpause the video and you're listening to me again. So usually I get one of two suggestions. One is like, well, I would start by subtracting away 25 cents. And then once it got to a point where I couldn't subtract away 25 cents because there wasn't enough money left, I would start subtracting away 10 cents. And then when there was not enough money left, I would start subtracting away 5 cents. And when there was not enough money left, I'd start subtracting away pennies. And I would just keep track of how many times I subtracted each coin. Right? And that will work. All right. We could write a program that works by that convention, but it would actually be a little tricky to write that program, a little bit beyond what we want to do right now. All right. We're going to try to keep it a little simpler at the start. So the other approach that kids usually take is division. And they say, well, I could take that number and I could divide it by 25. All right. So let me bring up a little calculator here. So calculator. So if I had 77 cents and I divided it by 25, it would tell me that it was 3.08. You might be saying to yourself, okay, so that means I need to give back 3/4, but then what do I do with the 0.08? Well, that's where this little integer variable comes in handy, because the integer variable is going to cut off the decimal. It's just going to ignore it. So if we divide 77 by 25, that's going to tell us exactly how many quarters we need, right? Because again, if we use integer variables, the decimals will not exist. All right, and then we could keep going on that process and so on and so forth. So that's the approach we're going to take, is we're going to take the division approach because it's a little easier to write. So if we go through our program here, we have int change that right now is empty. All right, I did not initialize it. I did not give it a value. Instead, we're going to let the user give it a value. So here I have a message, cout, enter the amount of change 0 to 99. Now, that's just a message, all right? It doesn't actually do anything. To let them input the actual number, I'm going to use a different command called cin, which allows us to take in input. So instead of the less than that I've been using for the cout, I'm going to use a greater than. That's the input operator. And what that's going to do is it's going to cause the program to basically pause until the user provides an input. All right, they're going to have to type in a number, and then they're going to have to hit enter, and that's going to provide the input. Now that input needs to be stored someplace. So what I do is I type the name of my variable, which is change. And what this is saying is take in input from the keyboard and then store it in the variable change. So in this way, I'm not setting it to a value like I did before in the example. I'm letting the user type in a value, and it's going to get stored inside of my variable. Now, this right here, again, is a little more advanced. So I'm not expecting you to write anything like this, but it's good to see it and just get exposed to some different code. This is like an error check. All right, so this is what's called a while loop, and it will keep repeating any code inside of these braces as long as one of these two things is true. All right, this is saying while change is less than 0. So if somebody was a jerk and they typed in a negative number, these two vertical lines mean or. So this is while change is less than 0 or change is greater than 99. So if somebody didn't follow the rules, what we're going to do is we're going to say cout. I said it had to be between 0 and 99. What the heck? Again, let me zoom out again. Try again. And then we're going to give them another cin statement. So I'm going to hit enter there and just tab over and go cin greater than change. Again, notice there's a semicolon at the end there. Notice there's a semicolon at the end here. Your programs will not work without those semicolons. All right, there are some lines that don't have semicolons, like you'll notice this one doesn't. But most of the lines that we write early on are all going to end with these semicolons. It sort of marks the end of the statement. So right now, if I were to run this, you're going to see it says enter the amount of change, and then there's like a flashing cursor because it's waiting for me to type something in. If I type in a -54, it's going to say, hey, try again. If I type in a 987, it's going to say, hey, try again. If I type in 100 exactly, it's going to say, hey, try again. It's not going to let me proceed until I type in a valid value. So if I were to type in 99, then my program ends. because that's a valid value. So how are we actually going to calculate the change? All right, well, what we're going to do is we're going to make a bunch of different variables. We're going to run through some calculations, and we're going to print those results out to the screen. That's basically the gist of this program. So we're going to go up here, and we're going to start by making a new variable called quarters. Now, you can make variables anywhere in your program, but the convention is to make all of your variables up at the top, so they're sort of in one spot. I'm going to make another variable called quarters. Okay, I'm going to have that semicolon there. Again, I didn't initialize it, so right at the start, it has no value. And then as soon as they type in their change and we have a valid value, I'm going to do my first calculation. So what I'm going to say is I'm going to say quarters, and that's going to be on the left-hand side all by itself, equals change divided by 25. Now, notice how I put spaces after the equal sign. I put spaces before and after the division sign. Again, you don't have to, but it's considered, good practice. It's kind of embarrassing because these should have spaces up here as well. So it just makes your code more readable. All right, it'll work either way, but it's considered good practice. So right now, this will now perform the calculation, whatever number they typed in, it will divide it by 25, and it will store that answer inside of my quarters variable. So if I want to print that out to the screen, I could go cout, less than, and I'm going to start with straight text. So starting with straight text means putting it in quotes. I'm going to put the word quarters. I'm going to put a colon in there. I'm going to put a space, and then I'm going to close my quotes. So that's just kind of like the formatting that I'm doing. Now I want to switch over to printing out a variable. All right, so the variable does not go inside of the quotes, and I can't just put it right here after. I have to use the output operator again, which is less than, then I can type the word quarters. All right, and because I didn't use quotes, it knows that I'm asking for the variable, not the word quarters. And then I'm going to use the output operator again, and then type end L. That's not a 1, that's an L, so that it hits the enter key. All right, so I've now calculated how many quarters to give back. So if I were to run this, and I was to type in 87, it would tell me that I need to give back 3 quarters. All right, so let's continue on. All right, you might be saying to yourself, oh, I got this. Let's make another variable. All right, so int dimes. And then if I want to know how many dimes are left, I would just go dimes equals change divided by 10. And then I could cout dimes end L, and you're kind of like, oh man, this programming stuff is easy. Like, this is going to be a breeze. All right, and I could run this just to make sure that it works. It's always a good idea to test things frequently so that you're not writing a whole bunch of code and then testing it. And the reason I say that is if there's a mistake, it's a lot easier if you're testing frequently because then there's only so many spots the mistake can be. If you try to write the whole program and test it at the end, the mistake could literally be anywhere. But if you're testing as you go, you sort of limit where the mistake could be. So let me type in 77. And it tells me that I need 3 quarters and 7 dimes. Well, that's not right because that's way more than 77 cents. I just got back way more money than I should. So what's happening here? All right. Now, this is the great thing or the horrible thing about programming is the computer's going to do exactly what you told it to do. So it did what we told it to do. We just didn't tell it to do the right thing. All right. We gave it bad instructions. All right. Yes, we calculated how many quarters were needed, but we didn't then subtract that money from our change. All right, so change right here, yeah, we divided it by 25, but when we divide it by 10, we never updated change. So it still has that same value it had at the start. all right? It's still the original 77 cents that it was. So what we might want to do is before we actually divide by 10, we could do something like change equals change minus however many quarters we gave back times 25, because that's how much a quarter is worth. All right, so what this is saying is take the old value of change, subtract quarters times 25, again, proper convention there, subtract quarters times 25, and then store this whole calculation inside of change. And again, I said this earlier, but this has to be all by itself on the left. The calculation has to be on the right. If I tried to flip those around, you would get an error. All right, so if I were to run this now, and close this out and try it again. Let's try 62 cents. It's going to tell me that I need back 2 quarters and 1 dime. All right, so what you are going to do at this point is finish this program. All right, so this should be enough to get you started, and you're going to want to finish it. So get the nickels and the pennies working so that at the end of it, it will give me a full report of how much change I need back. Now, when you are done and you are ready to submit this work, I want to show you what you're actually submitting. So I'm going back here to the File Explorer. This is the folder that everything is inside of, Intro to Making Change. This is the folder, the file that I need attached. All right, it's main.cpp. This is the file that actually contains your written code. So this is the file that I'm going to need to see to give you credit for this exercise. So again, when you go back to Google Classroom and you go to submit the assignment, you're going to have to attach your work. You're going to be uploading a file from your computer. Now, I can't really show that because I'm not a student, but what I can show is, if I was going to add an assignment, I'm adding a file, you're uploading a file, and then I'm not uploading it from my drive, I'm uploading it from my computer. So I would have to browse, go into the folder, and I'm getting this main.cpp. That's the file I need attached when you actually submit this assignment. All right, so if you have any questions, let me know, but I think you should be in a pretty good place now to sort of finish and bring this program home. All right, again, pay attention. All right, capitals matter, symbols matter, semicolons matter. Again, this is end L, not end one. All of these little things matter. All right, your program's not going to run just because it's close to being right. Your program's only going to run if it's actually right. All right, so you're going to need to use this compiler to try to find mistakes as they pop up. So for example, if I forget this semicolon and I try to run this, it's going to give me an error on line 28 saying expected semicolon before return. All right, if I suddenly try to use the word nickels without actually creating the variable, you're going to see that I get an error that says nickels was not declared in this scope, which is basically saying, hey, you forgot to make the variable up top. So you do have to be careful. There's things that you have to watch out for, but take your time, use this as your sort of framework, and you should be able to complete the rest of this on your own. All right. So best of luck and have a great day. Bye.